Does every team really need Kubernetes, or are we paying a complexity tax that shouldn't be necessary? In this episode of KubeFM, we sit down with Danyl, who's a veteran .NET engineer and architect at Eneco, to pressure test his thesis from "Not every problem needs Kubernetes." We get concrete about when K8s delivers compounding value, and when managed containers like AWS Fargate or Azure Container Apps win on simplicity. Danyl walks through the cost model, complexity, ownership, skills, time, why a modular monolith often beats premature microservices, and how platform engineering changes the build versus buy calculus. We also explore alternatives such as Dapper, Argo CD, and Actor/Beam runtimes, Erlang, Elixir, Orleans, Akka.net, for resilience without orchestration sprawl. Plus, the real edge cases where multi-region hybrid justify Kubernetes. If you're making 2025 infra choices, this episode will definitely sharpen your decision tree. Special thanks to TestCube for sponsoring today's episode. Need to run tests in air-gapped environments? TestCube works completely offline with your private registries and restricted infrastructure. Whether you're in government, healthcare, or finance, you could orchestrate all your testing tools, performance, API, and browser tests without any external dependencies. Certificate-based auth, private NPM registries, enterprise OAuth, it's all supported. Your compliance requirements finally met. Learn more at testcube.io. Now, let's get into the episode. Hi, Danyl. Welcome to KubeFM. What are 3 emerging Kubernetes tools that you are keeping an eye on?
Thank you. I'm glad to be here. I'm not a Kubernetes expert, so rather an engineer who knows how to build or deploy and run apps in Kubernetes, like write some YAML deployments, Helm charts, etc. So probably in this conversation we'll be mainly see things from perspective of engineer or architect. And for me, primarily as an engineer, some tools or any tools that helps improve developer experience is a point of interest. One of such tools probably will be Dapper, which stands for like a DAPR. I think it's also part of the CNCF. It's interesting, so keeping an eye on it. And next one probably will be ISP.NET Aspire. This is more related to .NET stack, which is I'm working in. And yeah, it's introduced by Microsoft in .NET 8, and it's a developer experience and application composition layer focused on building, wiring, and running distributed apps. So that's another tool, and probably I will mention Argo CD because that's something I used when I was working with Kubernetes deploying apps.
Very good. And for folks who don't know you, can you just give us a quick introduction about what you do and where you work?
Sure. I've been writing software professionally for more than 20 years. And during my career, roles ranged from software engineer to lead developer, technical lead, software architect. Early in my career, I started as a C++ engineer, but later switched to .NET. And I work in different companies, from startups and scale-ups to big enterprises. Also in various industries, automotive, telecom, agriculture, hospitality, banking, etc. Currently, I'm employed by Eneco, which is a producer of natural gas and supplier, electricity and heat in the Netherlands. And I'm working on architecting some business critical code and making it cloud native friendly.
Fantastic. And since you mentioned cloud native, how did you get into cloud native?
It was around 2013 when I was working for one of the startups, and we were building social network for house property owners, some local analog of Nextdoor probably. It was a quite ambitious project, and we were running back in time and on a local VPS hosting provider, having some virtual machine workloads, mainly Windows servers. And Azure was emerging at that time, and we started using some basic Azure functionality and services like running websites, then included mobile services, API management, and so on. So eventually migrating more workloads to the cloud. And that was my first experience with cloud. We didn't have a lot of documentation and guidelines on how to build cloud native application back in time. And I believe this cloud native term itself introduced much later. So it was a trial and error approach, experimentation, and it was a lot of fun.
Very good. And this ecosystem, when it comes to cloud native and Kubernetes, it's no secret that it moves quite quickly, or some would say very quickly. How do you keep up to date? Is it through blogs, through videos, official documentation? When, for example, the projects that you mentioned in the beginning, when you want to learn about Dapper, when you want to learn about Argo, where are the places that you go? I ask because we also have a monthly content analysis report where we track different trends about what people are looking at. What are the things that are most helpful? So in your case, how do you stay up to date with all the changes that are going on with these technologies?
I read a lot of blogs, of course, from various sources. From time to time, follow CNCF blogs, but as I mentioned, I'm not a Kubernetes expert, so keeping an eye on it. Also, there is a nice technology radar from Salesforce, where you can see some emerging and trending technologies, and the one which is probably you need to retire as well. I read quite a lot of books as well on different topics, technical books mainly. That is my sources probably.
Fantastic. And if you could go back in time and share one career tip with your younger self, what would it be?
I would say spend more time learning basics and foundation. Most of the things in our industry not new, and they were invented in 50s, 60s, 70s, 80s. So operation system compilers, network protocols, database internals. So they've all been there for decades. And what changes is the packaging, right? So the syntax and the hype. So I would say mastering the boring fundamentals is often most differentiating thing that you can do in the world which obsessed with the shiny new tools. Well, that's will be my tip.
Okay. As part of our monthly content discovery, we found an article that you wrote titled, "Not Every Problem Needs Kubernetes." So now I want to dig into this a little bit more. The article claims that 90% of teams don't need Kubernetes. Well, let that sink in. That could be controversial. Let's start with some context, though. How did Kubernetes become such a dominant force in container orchestration?
Yeah, sure. I think Docker exploded around a little bit more than 10 years ago, probably around 2013, by making containers usable for everyone. And I think containers solve the problem that it works on my machine by bundling code and dependencies. But then there is a problem. How do you run hundreds or thousands of containers in production? So then several orchestration tools emerged to solve the scheduling, service discovery, and scaling problems. So Docker Swarm, Mesos, and Kubernetes is only what I know. I'm sure it could be more. And while others existed, Kubernetes was open source, extensible, backed by Google, and I think it was also battle tested by Borg, which was a Google internal tooling for cluster manager. So Google open sourced its Borg like orchestrator at the right time, and CNCF plus cloud provider support created a snowball effect. So that put a big bold point in this orchestration wars and made Kubernetes the default choice, basically.
There's an argument that Kubernetes adoption is often driven by buzzwords and resume building rather than actual technical needs. What patterns have you observed in organizations when they're choosing Kubernetes?
Absolutely. One of the biggest pattern I've seen is that Kubernetes often enters room not through the clearly defined problem, but through aspiration. Teams want to level up, be cloud native, or match what they think like a big players do. And in many cases, this decision either politically or emotionally driven, but not often technically. So some examples I've seen that some early stage startups with maybe 5-10 developers or less and a single Node.js server, right? Or service, and they spend weeks containerizing everything and wiring Helm charts, all to deploy something that you could do probably and run on $20 or $20 VPS or Azure App Service. So ops overhead is huge, and it's basically what's slowing down them. Another example, for example, is a mid-sized enterprise where decision came from top down after few engineers attended KubeCon. So suddenly a small .NET monolith got split and shipped into a Kubernetes cluster. And then no one knew how to debug anything anymore. So deploying pipelines became fragile. And the cost of developer onboarding went up. Now I also worked for a media company that handled hundreds of video streams daily. On the surface, also sounds like a textbook use case for Kubernetes, right? So you have elasticity, batch workloads, some hardware scheduling, etc. And yes, indeed, they also benefit in a few areas there. They had some services that had to handle spikes in traffic, especially during elections or sports events. But here at least, most of the real media workloads also like actual transcoding or packaging were offloaded to external services, AWS or Azure, and team's actual job was orchestration, coordinating APIs and metadata availability. So even in this kind of a valid case, Kubernetes was maybe partially justified, but also slightly over-engineered for most of the workflows. And of course, there are a lot of valid use cases for Kubernetes companies with hundreds or millions customers, and often with some spiky and unpredictable usage patterns. That's a perfect case for Kubernetes.
The article suggests that most teams end up with a system so bloated and fragile when using Kubernetes. Is this a fair characterization, or does it reflect poor implementation rather than inherent platform issues?
I will first to say that Kubernetes itself is not a culprit. The platform powerful and flexible, but with that power comes enormous complexity, and most teams underestimate what it takes to own it responsibly. So Kubernetes can be, of course, clean, resilient, and efficient, but only in hands of a team with deep platform understanding, clear boundaries between infra and app responsibilities, operational discipline, security, CI/CD, etc. But without it, it's like, I don't know, giving Formula One car to someone who just got their driving license. So it's not a platform that's broken. It's how it's often it's misapplied, I would say.
The article mentions that without proper developer platforms built on top, Kubernetes becomes hostile to developers, requiring service meshes like Istio or runtime layers like Dapper. Is this additional complexity inevitable, or are there ways to keep Kubernetes developer-friendly without these layers?
And great question. And no, I don't think that all that complexity is inevitable. But without intentional design and developer hostile Kubernetes is default. Out of the box, Kubernetes is an infra tool and not a developer experience. So I think if we want developers to be productive on Kubernetes without throwing like a Dapper, ETL, or entire platform engineering organization and the platform, the problem, and then you need to build at least a lightweight developer experience layer. So probably at minimum, it should be some simple deployment tooling because kubectl probably would not be enough. This should have clear abstractions, hide in YAML as much as possible. Don't make add deaths, write, like horizontal pod autoscaler configs. Of course, it should have built-in observability, like login tracing metrics out of the box. Yeah, and preferably without asking devs to configure Prometheus or rules or stuff like that. Should be easy to roll back and preview environment. It's not the friendly unless it's debuggable and also reversible. So with those in place, Kubernetes become tolerable, maybe even smooth for developers. Without, it could be a jungle of YAML and role-based access errors and all the other guesswork. And what about meshes? Service meshes like it's your linker runtime like Dapper, they solve real problems like traffic routing, like retries, telemetry, circuit breakers, etc. But those problems only arise at certain level of complexity. So you probably don't need them if you have handful of internal APIs, your network topology is basic, and you're not doing complex routing per tenant policy. But if you run in dozens of microservices and with some zero trust requirements, blue-green rollouts, some multi-tenant traffic policies, then service meshes like Dapper-like sidecar can simplify things. And ironically, by centralizing the complexity that would otherwise be scattered across app code. So still, those layers are not free. They require operational expertise, upgrades and compatibility management, and also some debugging skills. So unless you really need those features, it's often better to delay adoption and don't add complexity. It's just in the name of being cloud native, I would guess.
There's an interesting point about Beam referring to Erlang and Elixir and actor models as alternatives for fault tolerance and scalability without orchestration complexity. How do you see these architectural patterns comparing to the Kubernetes approach?
Right. This is a hugely under-discussed area. So while Kubernetes has become a default tool for orchestrating, it's not the only or even not the most elegant way to achieve it. So actor models like Eka, like Orleans or Proto.actor and Beam-based runtimes, I mean here Elixir and Erlang, they offer a radically different paradigm and one that bakes fault tolerance to the application layer itself. So both Kubernetes and actor-based model aim to solve problems like resilience and fault tolerance, scalability, but the approach is different. So they come to that from opposite ends. So Kubernetes is platform agnostic, right? But it's heavy, but it's appealing as well because it's language agnostic. It provides a unified control plane for compute, storage, networking, and it's baked by all major cloud providers nowadays and ecosystems. But it achieves reliability through external orchestration. So you have lines, probes, sidecars, nodes rescheduling, and the application itself unaware of its own life cycle. And that decoupling comes at cost. So a lot of plumbing, right? YAML, operational burn. So how Beam and actor model solves it? Beam runtimes like Erlang, Elixir, and other actor model systems, they offer intrinsic resilience. So crashing is expected and even embraced. Supervisors automatically restart failed processes. Processes isolated and externally lightweight, extremely lightweight. And you get the distributed messaging, concurrency, fault recovery, and without need an orchestrator. So when you build apps in Elixir or Erlang, then fault tolerance is not battled on. It's the foundation. And similarly, .NET Orleans or AK.NET, which is more familiar to me as I'm from .NET world, they give you virtual actors with some concepts like location transparency, automatic lifecycle management. So those systems scale horizontally without thinking in terms of pods or deployments. It's just actors and messages. And too many teams jump in Kubernetes for scalability and resilience without realizing those could be achieved with less complexity if you choose the right runtime model. So don't always need a cluster of nodes. Sometimes you just need a runtime that knows how to take care of itself, like a beam, for example. So I would say Kubernetes is a general purpose tool, and actor model, they purposely built for this exact problem. So if you can afford to go all in to those paradigms and using actor models, they will often get you there faster and cheaper with less configuration, like YAML, right? So you write the code, you write in high level languages, and the code knows how to handle themselves.
The article critiques teams that claim to have hundreds of microservices, but actually have distributed monoliths with tightly coupled services. How can teams honestly evaluate whether their architecture truly benefits from Kubernetes orchestration?
Yeah, this hits a nerve. Many teams proudly claim that, we have 300 or 400 microservices, but under the hood, it's often a spaghetti mess of services that you can't deploy independently, or they fail together, or they know too much about each other internal state. So that's not really microservices. It's just a distributed monolith. And Kubernetes won't fix this problem. So it might even make it worse by giving you just enough scaffolding to pretend it's working until it doesn't. So real microservices or microservice architecture has certain aspects to it, right? So a service should be independently deployable without coordination, owned by distinct teams with clear domain boundaries. And they should communicate over well-defined APIs or events, but not internal contracts. So they can fail independently without the cascading impact. They should use separate storage or at least separate schema to reduce coupling. And they should be tested and versioned in isolation. So then, if all of this is true, I think this is the right track of building microservices. Otherwise, that's probably not. So I would say Kubernetes is great in managing complexity, but it won't save you from complexity which you invent yourself.
Platform engineering is presented as essential for Kubernetes success, with the article suggesting that most organizations can't compete with managed services from major cloud providers. What's your view on build versus buy for developer platforms?
Yeah, this is an important point, and one that too often gets glossed over in Kubernetes kind of evangelism. So I think platform engineering is essential for Kubernetes to succeed in any meaningful and sustainable way. But also there is a catch that most companies are not in, or many companies not in a position to build reliable platform. Nor should they try. So building an internal developer platform on top of Kubernetes, it's not only or isn't about writing some YAML templates and adding CI pipeline. So it requires the dedicated team of platform engineers that has strong infra as code practices, HitOps culture, consistent monitoring, logging, tracing, alerting across all services. So it should support some model of onboarding and training, and as well as incident response. And this is like a real engineering effort. Unless you have at least 3 or 5 experienced engineers dedicated to platform work, internal platform is likely to become more of a patchwork of half solution that developers quietly present. So I think it's uncomfortable truth that cloud providers have already built great platforms, and they will do it better, cheaper, and more securely than 95% of internal teams. So, for example, Azure App Services, AWS, App Runner, Google Cloud Run, all offer managed deployment, auto scaling, zero cluster operations, and easy rollback. Then we have what is Backstage, Humanitech, and other internal developer platforms that let you expose self-service infrastructure portals without starting from scratch. So my take is that if you're not ready to treat your platform like a product with complete roadmap, support, lifecycle management, you probably shouldn't build one.
The legitimate use cases mentioned include multi-region redundancy and hybrid cloud environments. Are these requirements becoming more common? Or are they still edge cases for most organizations?
Because multi-region and hybrid cloud gets thrown around a lot as a justification for Kubernetes and having infrastructure, for most organizations, I think they are still edge cases. But real need emerge when you are somehow legally or contractually required to keep data in specific regions. That could be, for example, German data residency law, or you serve latency sensitive workloads across continents, right? With low latency gaming, for example, live trading, stuff like that. Or you running workloads on-prem due to some hardware requirements or legacy integrations. So in these cases, Kubernetes might help. But I think you're not adopting Kubernetes because you are multi-region. You're adopting it despite the complexity of multi-region. It helps to orchestrate some of it, but most of the pain is still for you to own, because even Kubernetes don't solve multi-region problems for you. So you still need to build things like global DNS or traffic routing, data replication strategies, cross-region service discovery. So that's could be a pain, but I think for most companies, you just don't need it. But if you need it, go for it.
There's a provocative statement that DevOps is not a role, it's a practice, in the context of needing dedicated Kubernetes teams. So how should organizations approach the skills and team structure needed for Kubernetes?
Yes, DevOps is a practice, not a job title. And that doesn't mean that you don't need dedicated people doing the operational work. DevOps as a movement is about collaboration, automation, some shared responsibility, breaking silos between devs and ops. But the idea is to empower teams to build, test, and deploy on their own. But exactly what I wanted to say, that Kubernetes also doesn't magically make it happen. In some cases, it reintroduces silos because then complexity is so high that only a few people can manage it. So ironically, you end up needing a dedicated SRE team or platform team, right? And everyone then is doing DevOps. Even if everyone is doing DevOps, so you still need these teams. So instead of asking who should own DevOps, probably you could also ask how we structure teams so that product teams can ship safely and quickly and on their own, so autonomously. without, again, drowning in a lot of YAMLs. So sometimes the answer could be Kubernetes and platform team. Sometimes it just could be app services and some DevSecOps pipeline. And sometimes it's just don't use Kubernetes at all. It depends.
The article suggests starting with monoliths on VMs with auto-scaling before considering Kubernetes. This seems to go against the microservices first trend. What's your take on this evolutionary approach to architecture?
Yeah, I'm not just saying monoliths. I'm more advocating for a modular monolith or monolith, if you wish, as a first architectural step. And this isn't the nostalgia or fear of scale. It's about simplicity and evolutionary design. So giving your system room to grow without forcing you to maintain 15 distributed services before your product has even has a traction. So why to start with monolith? Because it gives you best of both worlds. So deployment simplicity of a monolith and logical separation and stability of microservices. So also, if it is a modular, or because it's important to have system built in a modular way. So then the ability to refactor and extract later is justified as well. So you can transition to microservices way easier. But if your architecture is clean internally as well, so you can extract modules into services right later. You can deploy features independently within one artifact, or keeps observability, debugging, testing straightforward. So you kind of delaying the operational tax of the distributed systems until you are really ready for the load and the scale. So I think a well-designed monolith teaches just good boundaries before distributing those boundaries across a network. And when to evolve to microservices, I think it's a module is hot and scaling disproportionately. If your model is very on a hot path and scaling disproportionately, for example, it has some pricing engine or some encoding happening there, or you hit some team level friction where multiple groups step in on the same code deployment, or you need isolation, deployment independence, etc. Then at this point you start extracting, but you doing that based on some real signals, right? Not hype. So I would say too many teams chase microservices early because it sounds cool and they want to mimic big tech, and they think it's the only modern way to scale, but they don't have enough engineers to support big amount of deployments and CI pipelines, proper observability, tracing, alerting in place. So if you don't have this, then, or for example, if you don't have a real product market fit, then you build in probably something like distributed monolith, which is tightly coupled and with fragile integration points. So I think I would say get the structure right and keep deployment simple and evolve based on real needs, not pressure from outside.
Container services like AWS, Fargate, and Azure Container Apps are positioned as middle ground between traditional deployment and full Kubernetes. How do you evaluate when these solutions are sufficient versus needing full orchestration?
Yeah, exactly. I see services like AWS, Fargate, or Azure Container Apps like a sweet spot for most teams They give you containerization benefits like isolation, packaging, portability without the pain of managing Kubernetes control plane or worrying about nodes, pools, ingress controllers, cluster upgrades. So they are really fantastic middle ground and often sufficient for probably 80 to 90% of use cases. So I would say, it's you could stick with one of those tools and services when you have like stateless services, APIs, or background jobs. You have some simple auto scaling, and when you want to move fast and deploy without worrying about infra, so your app fits the cloud provider opinionated runtime. So no need for advanced scheduling or sidecars. So you are focused also on cost efficiency and some developer velocity. Then I think all these tools are really in sweet spot for you. For example, a team I worked with, deployed like 10 plus services across environment using Azure Container Apps. And Dapper for lightweight messaging, they didn't need full Kubernetes, and then they shipped features weeks faster with fewer operational headaches. So I think Kubernetes should be an exception, not the starting point. For most teams, managed container services are more than enough.
The article implies that Kubernetes adoption is often driven by resume building or following trends rather than solving real problems. How can technical leaders make more objective infrastructure decisions?
Yeah, and this is one of the core frustrations that inspired the article. So too many infrastructure decisions starts with, hey, everyone's using Kubernetes, we should too, instead of, what problem are we trying to solve, and is Kubernetes the best fit? I think as technical leaders, our job isn't to chase innovation, it's to protect focus and simplicity. That means filtering out the hype and making some deliberate and grounded choices. I think if we ask questions, what is the actual job we need this tool to do? And can that job be done with simpler or existing tools? Also, we can throw some cost model here, which stands for complexity, ownership, skills, and time. So then for complexity, we ask, what new cognitive or system complexity does it add? Then ownership, who will own and maintain it after the excitement fades? Then skills, okay, do we have the necessary in-house expertise, or we will become dependent on some one hero engineer? Also on time scale, what is a ramp up time to value, and can we afford that? So one of the healthiest habits leaders can cultivate is running small scoped experiments, right? Like try Kubernetes for one non-critical service first, measure not just performance, but deployment velocity, developer happiness, maintenance overhead. Run the same service on a managed container platform and compare. Then you document all this glue code and tribal knowledge required to run it in Kubernetes. That's your hidden cost. So some strategies for separating hype from value, that's should probably challenge the buzzword fluency, like ask people to describe technical choices in plain terms. And if the case for Kubernetes can be made without acronyms, it probably isn't strong enough. I think also we should involve product teams and ask them what they need to what they need to ship faster, right? If they don't mention custom pod affinity rules, that tell you something. Also, I think we could hold some technical justification reviews. Before adopting any tool, team must answer what pain is this solving and what happens if we don't adopt it. So if Kubernetes is the right tool, it's great. But if it's not, don't be afraid to choose boring, reliable, and well understood tech.
While the article is quite critical, Kubernetes, at the end of the day, has become the de facto standard for container orchestration. What are the genuine innovations and benefits that Kubernetes has brought to the industry, even if it is overused?
Yeah, absolutely. While the article is intentionally critical, it's not anti-Kubernetes. It's anti-blind adoption. So Kubernetes has brought massive, undeniable innovation to the industry, even if it's been over-applied in places it doesn't belong. But we should give a credit where it's due. Before Kubernetes, we had a wild west of like do-it-yourself scripts, hand-rolled like bash deployments, and all the other nice stuff. So what Kubernetes gave industry is a common vocabulary, right? So you have pods, services, deployments, volumes, etc. You have standard API for interacting with clusters, and you had a modular model that also allow extensibility via like CRDs and operators, controllers. And this created a level of portability and predictability across teams, clouds, and companies that simply didn't exist before. So it's the reason now we now expect a containerized app to just work across environments. So Kubernetes also embraced the idea of immutable deployments. So where you build once and then run everywhere, anywhere. Declarative infra and version control. So Git as a source of truth. Tools like Argo CD I mentioned in the beginning, like GitOps culture, self-healing behavior through controllers and reconciliation loops, etc. I think these ideas weren't new, but Kubernetes turned them into practical defaults. And from that came modern practices, progressive delivery, infrastructure, drift detection, correction, heat ops, all this Argo CD Flux tools. And also the fun fact, but I think Kubernetes also succeeded in a way by highlighting its own complexity, and that pressure led to the rise of actually things like base cloud providers do, right? Like Azure Cloud, container apps, Google Cloud Run, and AWS and Eneco. So other things on the plate is like K3s, micro KA Kubernetes, and serverless Kubernetes platforms. Again, abstractions like Dapper, Knative, and analogs. I think they all appeared as some response to complexity of Kubernetes, right? To help to people who are using it. So this wouldn't exist without Kubernetes setting a bar that others wanted to meet and exceeded, but in a more friendly way. So my argument isn't that Kubernetes is bad, it's that Kubernetes is very powerful, and like any powerful tool should be used with intent, but probably not by default.
It was last year that we celebrated 10 years of Kubernetes, and we've asked quite a few people about what they expect to happen in the future. So looking forward, looking at the future, do you see the pendulum swinging back towards simpler solutions, or will the complexity of Kubernetes eventually be abstracted away enough to make it accessible to all teams?
Yeah, I will see this pendulum swinging back towards simplification, and it's already happening. The industry is starting to collectively admit things like, okay, Kubernetes is powerful, but do we really need all of this for most workloads? And then we are seeing shift from like a raw orchestration power towards some better developer experience, some abstractions, and just enough infrastructure. So platforms, again, like mentioned, Azure Container Apps, and same on Google and AWS, they are taking something like 80-20 of Kubernetes, and baking it into a zero ops experience. So you bring the container, they handle scaling, network certifications, routing. So other tools like internal developer platforms, again, Backstage, Humanitech, other one. They teams are abstracting Kubernetes, right? They call it golden path templates, right? And rapid and self-service UIs, so that devs never even touch some configuration YAMLs. So there are like projects like Pulumi, Dagger, right? And there are things like Kubernetes Lite runtimes, K3s, Micro K8s, and other. So I think we'll still be using Kubernetes under the hood, but most devs won't know or care. It will be part of platform as a service, like platform with opinionated defaults and tight feedback loops. So I think we won't stop using Kubernetes. We will stop talking about it. So it's more about like less Kubernetes in your face, right? So you can use some abstractions and some nice tooling around it, so that very friendly to developers to use without necessity to go deep dive and understand all behind it.
One counter argument to the article's thesis is that Kubernetes represents necessary complexity, that the problems it solves are inherently difficult and simpler solutions are often incomplete. Do you see this complexity as fundamental to the problem space, or will we eventually see tools that can abstract it away while maintaining the same capabilities?
Yeah, it's a fair counterpoint, and one that I also agree with in part. So yes, distributed systems inherently complex, because you need to deal with partial failures, the network partitions, scheduling, auto-scaling, security, all the stuff. And there is no silver bullet. So in that sense, Kubernetes isn't introducing complexity, right? It's surfacing and managing it. It's just that in doing so, it also exposes the fire hose of knobs and levelers. So most teams aren't equipped to handle. And Kubernetes tries to abstract away some essential complexity, like scheduling, auto healing, but it also introduces a lot of accidental complexity. Again, YAML, CRDs, operators, Helm versus customized, right? Like cargo, etc. So the danger is that many teams who adopt Kubernetes thinking they are getting simplicity, but they are actually trading one class of complexity for another, probably harder to debug one. So can we abstract Kubernetes without losing power? I think we are getting closer, and there are some emerging patterns which show some promise. We all mentioned it and repeating again. All these big players, big platforms are doing that with Azure Container Apps, AWS App Runner, etc. Those services hide the cluster entirely, but still offer you auto-scaling metrics and networking, and they are Kubernetes back. So right behind the scenes, they're still running on Kubernetes, but a user never touch anything out of that, like YAML. And another thing is the platform is a product. Internal platforms allow things to build all these paved roads and self-service portals, so which you could surface just enough control without exposing like every knob that Kubernetes has. Tools probably like cross-plane port, let team orchestrate infra, also declaratively across clouds without hand writing manifest. So you can abstract complexity, but you can't delete it. So Kubernetes solves hard problems, but that doesn't mean you have those problems. Its complexity is often justified at certain scale, but premature exposure to that complexity is what hurts teams. I think the future isn't about dumbing it down. It's about designing platforms that let us grow into this complexity only when we actually need it. So I think smart tools, some sensible defaults, and fewer full guns. And that's what will win, not like less Kubernetes, but less Kubernetes in your face.
With that in mind, what's next for Kubernetes? What's next for you?
All right. I continue working on migrating some legacy applications to cloud native, and shaping some architecture to align with team topologies and value streams, all that nice stuff. On my side quest projects, I really want to find time and dive into this beautiful world of actually Elixir and Erlang a bit deeper, and also in the beams, actor model, to explore this true power of this fault tolerance and scalability. That's something on my mind as well.
Very good. The topic that you chose for today may cause a little bit of controversy. I'm sure you've already experienced people with opinions, but whether people disagree or agree, what's the best way to get in touch with you?
Yeah, I'm on LinkedIn, so feel free to drop a message. I'm often checking it. I think that will be probably the best source.
Fantastic. Well, Danyl, thank you so much for sharing your knowledge with us today. Look forward to interacting with you in the future. Take care.
Thank you very much.